What's up, old man? This is our pulley system. The system has 4 pulleys and 5 ropes.
So this system has an ideal mechanical advantage of 15 to 1, meaning that since there's a 15-pound weight right here, we will need to apply 1 pound force here to lift the weight up. If we take into account the friction between the rope and the pulley, we need to apply more force, meaning that the mechanical advantage will be around 14 to 1. So here's a demonstration of how it works. Here I'm applying 1 pound force just to lift the weight up. Okay, you don't believe that was 1 pound force and you think my fingers are jacked? Here's a demonstration with the bottom. That is around 1 pound. How does this system work? Let's take a look at the rope. So earlier we applied 1 pound force here. That means since this is the same rope, this will be 1 pound force here. This rope is being pulled down by these two, so this rope would be, the tension here will be double of this, meaning this will be going to be pulling up 2 pounds of force. The same concept applies for the last 2 ropes. So this one will be double of this one, meaning this will pull up 4 pounds of force, and this one will be double of this one, meaning we'll be pulling up 8 pounds of force. In total, this is 1, 2, 4, and 8. That makes 15 in total. That is why the mechanical advantage is 15 to 1.
The system is not very efficient because when you pull down a foot, this part will only move half a foot, a quarter, and an eighth, meaning that the weight will move a lot less than how much you pull down. Even though you need to pull down more distance to lift up the weight, the system is very efficient for 4 pulleys and 5 strings because the effort is approximately reduced by 15 times.
Okay, so this is a diagram of our first system. It has a ideal mechanical advantage of 15 to 1, and here's why. So let's say you apply T force on this rope. So this is the same rope. T, this will also be T for this rope because it's the same. This force will be, the tension of this rope will be 2T because there's 2T right here pulling it down. And this is the same rope, this will be 2T as well. The same concept applies to the last 2 ropes. This one has a tension of 4T because this is 2T and 2T. This one has a tension of 8T because there's 4T and 4T. In total, we will have to add all of these numbers to come up with a tension for this one. So 8, 4, 2, and 1, that makes 15T. So that's why the ideal mechanical advantage is 15 to 1.
To take account of friction, our actual mechanical advantage would be 14 to 1 because to lift the 15-pound weight, we would need a little bit over 1 pound, so we did 1.1. And that will give us our actual mechanical advantage. So to get it, we would do 15 over 1.1, which is approximately 14. And our efficiency for the system is actual mechanical advantage over ideal, which is 14 over 15 times 100, which gets us about 93.3% efficiency.